Hello students, I am Dr. Abhilasha Durgbanshi, Assistant Professor, Department of Chemistry, Dr. Hari Singh Gaur Vishwavidyalaya Sagar, Madhya Pradesh. Today, I am going to present a lecture of BSc 5th semester on the unit General Idea and Examinations of Organic Solvents, which has been jointly prepared by me and Priyanka Pahade, PhD Scholar UGC JRF, Department of Criminology and Forensic Science, Dr. Hari Singh Gaur Vishwavidyalaya Sagar, Madhya Pradesh. Let's start our discussion while taking a look at what we are going to learn today. In Module 1, we will discuss about Introduction and Definition of Organic Solvents. Module 2 will explain us the classification of organic solvents. In Module 3, we will talk about preliminary examination of organic solvents. Module 4 will cover about confirmatory examination of organic solvents. Module 5 we will discuss the forensic importance of solvents, and in Module 6 we will conclude with conclusion. Dear students, today I came with a new and interesting lecture which is based on organic solvents. Everyone in most of their daily activities use organic solvents, which can be in the form of decontaminators, stain removers, perfume, fragrance products, body spray and many more. All these products contain one of the ingredients known as organic solvent. The organic solvents commonly used in forensic toxicology are ethyl alcohol, methanol, chloroform, ethylene glycol, petroleum products, kerosene, etc. Now first we will talk about ethyl alcohol, ethanol or ethyl alcohol. The melting point of ethyl alcohol is 114 degrees centigrade. The boiling point is 78 degrees centigrade. It is a clear colorless liquid widely used in alcoholic beverages, ingredients, synthetic chemicals, solvents, germicide, antifreeze and gasoline additives. It is produced by the fermentation of carbohydrates or by the hydration of ethylene as shown by the following two reactions. In the first reaction, glucose is reacting with many alcoholic beverages containing ethanol. Ethanol is misused in beverages. It is responsible for more death than any other chemical. While considering death due to chronic alcoholism, vehicle fatalities caused by intoxicated drivers and alcohol related homicides, the metabolism includes as alcohol enters into the body, approximately 2 to 10% dose does not metabolize and is excreted from the organism in unchanged form through urine, exhaled air, saliva and feces. Other amount of alcohol are metabolized, which is oxidized to water and carbon dioxide. Another part is oxidized to acetaldehyde and then to acetic acid. Some medicines like antabus, teturam delay the transformation of acetaldehyde to acetic acid. The second organic solvent is methanol. We also call it methyl alcohol. It is a colorless liquid with boiling point 64.5 degrees centigrade and density 0.79. It could be easily mixed with water and many other organic solvents. The smell and taste of methanol does not differ from ethanol. Methanol poisoning is generally caused by undistilled or homemade alcoholic drinks or beverages, as some amount of methanol is also produced while preparing these alcoholic beverages. The major commercial source of methanol is by the destructive distillation, that is pyrolysis of wood, a process that yields a product contaminated with allyl alcohol, acetone and acetic acid. Now, methanol is synthesized by the following reaction of hydrogen gas and carbon monoxide. Both are readily obtained from natural gas or coal gas. Here in this chemical reaction, we see that methanol is generally used for the manufacture of formaldehyde. Additional uses include the synthesis of other chemicals including acetic acid, applications as an organic solvent and addition to unleaded gasoline for fuel, antifreeze and anti-knock properties. Methanol has been responsible for the death of many humans who ingested it accidentally or as a substitute for beverage ethanol. Now, the metabolism, the maximum amount of methanol collects in the liver and then in the kidneys. A metabolite of methanol is the formaldehyde, which is oxidized to formic acid. The part of this acid is decomposed to carbon dioxide and water. The non-metabolized methanol gets eliminated from exhaled air. The third organic solvent that we are going to study is chloroform. Chloroform molecular formula is CH-Cl3. It is a colorless, transparent, fugitive liquid which is characteristic of smell. It mixes with diethyl ether, ethanol and other organic solvents and is weakly soluble, dissolves in water under influence of light, air, moisture and temperature. Chloroform gradually decomposes forming phosgene, formic acid, hydrochloric acids. For performing certain chemical tests, we need chloroform in our laboratories as a solvent. It is widely used in a chemical industry. Earlier, it was also used as a medicine for narcosis. Chloroform vapor easily enter in organisms with inhaled air. Chloroform acts on the central nervous system causing narcosis. It collects in tissues and fats. When absorbed in large amount, chloroform causes dystrophy of internal organs, especially liver. Poisoning due to chloroform causes death from respiration failure. The metabolism includes chloroform when comes in contact with our body gets quickly disappeared from blood within 15 to 20 minutes with the exhaled air in unchanged form, which eliminates around 30 to 50% of chloroform. During the first hours, 90% of chloroform is eliminated through lungs. Rest part of chloroform is then available for biotransformation, forming carbon dioxide and hydrogen chloride as metabolites. The next organic solvent that we are going to study is acetone. The chemical formula of acetone is CH3COCH3. It is also known as dimethyl ketone or propanone. It is a colorless mobile liquid which has a boiling point of 56.3 degrees centigrade with characteristic odor. It mixes itself with water, ethanol and diethyl ether. Acetone also dissolves salts of many mineral acids and many organic compounds. Acetone is mainly obtained by dry distillation of tree coal or by chemical synthesis. Acetone is widely used in industry and laboratory as a solvent for extraction of many substances and analyte from matrix, for crystalline modification of chemical compounds, for dry cleaning, for chloroform synthesis, etc. Acetone vapors are heavier than air. Therefore, in rooms in which acetone evaporates, is danger of poisoning by inhalation persists. Acetone shows narcotic action. It has cumulative properties. The acetone is slowly excreted from organisms. It enters into the organism with inhaled air and also through the alimentary canal and skin. After entering the blood, acetone is a blood passes to brain, liver, kidney, lungs and heart, but acetone concentration in these organs are very low than in blood. The metabolism of acetone shows that some part of acetone which has entered into the organism transforms to carbon dioxide. Some amount of acetone is eliminated from body with exhaled air and through skin, and some passes through urine. Next organic compound is petrol. Petrol, which is a highly inflammable liquid, generally used as a fuel in the spark ignition engines. It consists essentially of C5 to C10 hydrocarbons. Chemical motor petrol is a blend of paraffins, isoparaffins, olefins, naphthalenes and aromatics, peona, along with additives which are normally added to enhance various performance features related to the satisfactory operation of engines as well as to minimize fuel handling and storage. Dyes are usually added for identification in solid or liquid form. Orange dyes are added for regular petrol, red dyes are added for premium petrol and green dyes are added for aviation gasoline. The next organic solvent is kerosene. Kerosene is a fuel oil which is a complex mixture of compounds of carbon and hydrogen. It cannot be defined exactly by chemical formula or definite physical properties. Two broad classifications are generally recognized. The first one is distillate fuel oils and the second one is residual fuel oils. The latter are often referred to as heavy fuel oils and contains distillates. Example, furnace oil, distillate fuel oils are petroleum fractions that have been vaporized and condensed. Distilled fuels are produced by distillation process in which petroleum is separated into fractions according to their boiling range. Kerosene and diesel, they are collectively called gas oil, are typical example of distillate fuels. Kerosene normally boils in the range of 150 degree centigrade to 250 degree centigrade, maximum is 300 degree centigrade and consists of C11 to C18 hydrocarbons. Kerosene is a blend of paraffins, naphthalenes and aromatics wherein paraffins and naphthalenes as major component and aromatics as minor components. Two types of kerosenes are normally available commercially. The first one is kerosene which is colorless, regular blue dyed kerosene for public distribution supply, we call it PDS. Based upon the structure and the functional group, the different type of organic solvents are as explained below. The first one is aliphatic solvents. These solvents belong to the class of alkenes. They are said to be non-polar in nature. Some of the applications of such solvents include oil extraction, paint, dye, pharmaceuticals in polymerization and additives, etc. Hexane, benzene, aromatic solvents like aliphatic, they are said to be non-polar solvents. They are utilized as industrial solvents for adhesives, paints, printing inks, extraction processes, decreasing in insecticides, etc. Example, toluene, xylene, carbonyl. The third is carbonyl solvents. These include esters. They are said to exhibit polar properties and are used in the nail paint removers, electronic cleaners, circuit boards, decaffeination, in glues and also in food flavoring substances. Example is acetone. Some of the other solvents includes alcohols which are used in various industries and commercial applications. For the preliminary examination of ethanol, we have iodoform test. In this test, we take 1 to 2 ml of ethyl alcohol in a test tube and then add few drops of 10% sodium hydroxide, followed by drop-wise addition of iodine solution till brown color appears. The mixture is warmed on low flame. After that, few drops of NaOH solution is added to change the color of the solution from brown to yellow. It is then cooled. The precipitate is observed under microscope. Characteristics hexagonal crystals of iodoform are seen. The second test is sulphomolybdic acid. Reagent preparation is, we take 1 gram of molybdic acid in 25 ml of concentrated sulphuric acid and then we take 2 ml of distillate in a test tube and we add 2 ml of the hot reagent. A deep blue ring appears at the junction of two liquids. On shaking, the whole mixture becomes blue. It indicates the presence of ethyl alcohol. The third test is ethyl benzoate test. In this test, we take 2 drops of benzoyl chloride. It is added to 2 ml of the distillate. The mixture is made alkaline by adding 10 ml of sodium hydroxide, which is NaOH, drop by drop. On warming, irritating smell of benzoyl chloride disappears and the sweet fruity odor of ethyl benzoate appears. Now, the preliminary examination we will see for methanol. By preliminary examination, the first test is Schiff's reagent test. It is also known as decolorized basic fuchsin. Take 4 to 5 ml of the distillate, add 0.5 ml of ethyl alcohol, 2 ml of 3% potassium permanganate, which is KMnO4 solution, and 0.2 ml of phosphoric acid and set aside for 10 minutes. After that, 1 ml of oxalic acid is added, followed by 1 ml of sulphuric acid. Then it is cooled at room temperature. 5 ml of Schiff reagent is added to it and the color is observed after 30 minutes. Purple color appears if methanol is present. The blank test is also performed side by side. The quantitation may also be made by matching the intensity of color developed with different known standards of methanol. The second is chromotropic acid test. Take a small amount of the distillate in a test tube. To it you have to add 0.2 ml of 5% potassium permanganate solution. After 5 minutes, saturated solution of sodium bisulfite is added drop by drop until the permanganate color disappears. If a brown color still persists, a drop of phosphoric acid is again added to it. To this colorless solution, 0.5 ml of freshly prepared chromotropic acid solution, which is prepared by dissolving 5 grams of sodium salt of chromotropic acid in 10 ml of concentrated sulphuric acid, is added and then heated on a water bath at 60 degrees centigrade for 30 minutes and they cooled thereafter. A violet color is observed. The next is the preliminary examination of chloroform. So, the first test that can be performed is Fujiwara test. In this, we take 1 ml of distillate and 1 ml of pyridine and then we add 2 ml of 20% sodium hydroxide solution is added in a test tube, and this is heated on a water bath for 1 minute. A pink to red color indicates the presence of chloroform. Chloroform and polyhalogenated compounds respond to this test. The second test is Nessler's reagent test. In this, we take 1 ml of the distillate, 1 ml of the Nessler reagent is added, no brown precipitate is formed, which differentiate chloroform from chloral hydrate. In the third test, we can take 1 ml of the distillate and 1 ml of strong alkaline solution of alpha naphthol is added and then heated. A blue color turning to green and finally to brown is observed. Next, we will see the preliminary examination of acetone. For acetone, the first test that can be performed is iodoform test. In this, we take 2 ml of the distillate and then 2 ml of a few drops of 10% NaOH is added. This is followed by dropwise addition till the solution becomes brown. The mixture is warmed on low flame. A few drops of NaOH solution is added to change the color of the solution from brown to yellow. Addition of a few drops of iodine solution is required. If on warming the solution becomes colorless, it is cooled. The precipitate is observed under microscope. Crystals are formed often on standing. Characteristic hexagonal crystals of iodoform are seen. The second test is Legal's test. To 1 ml of the distillate, we add 2 drops of saturated solution of sodium nitroprusside that is freshly prepared and 1 drop of 10% sodium hydroxide is also added. A red or yellowish color is produced. A few drops of glacial acetic acid is then added to acidify the solution, which changes the color to carmine or purple red. Subsequently, the solution is heated, which produces violet color. The next is the preliminary examination of petrol. Examination of petrol is generally conducted for examination of adulterants. The common adulterations involved oil orange dye, phenyl azo2 naphthol, which is used for coloring petrol. It is an azo dye. Preliminary examination can be done by we can do visual examination. Note down the color of the sample visually. The second is by UV visible spectrophotometry. Note down the wavelength in the range of 400 nanometers to 700 nanometers for orange dyes and red dyes using visible spectrophotometer. Oil orange dye we use 470 nanometers. For oil red dyes we use 505 as the maximum wavelength. The third method by which we can test these is thin layer chromatographic method for the detection of oil soluble dyes. The solvent system that we are going to use here is hexane toluene acetic acid in the ratio of 50:50:2. The developing reagent which will be used here is dilute sulfuric acid. What we observe is pink color spot as 0.49 retention factor, orange at 0.51 retention factor. The fourth method is by TLC and HPTLC for detection of petrol. The solvent system that we can use here is hexane and toluene acetic acid in the same ratio of 50:50:2. The development can be done by spraying the plate with rhodamine solution. This is prepared in 1% volume by volume in alcohol followed by bromination. Then the plate is observed under UV light at 360 nanometers. In the observation we see that pinkish orange fluorescence for petrol. If this pinkish orange fluorescence persists, then it is petrol. The next is filter paper test for detecting adulteration of petrol with diesel and kerosene. Take a filter paper of good quality and add 2 drops of petrol on a filter paper. If the petrol is unadulterated, then there will be no patch or mark left on the filter paper. If the filter paper is adulterated with kerosene and diesel, it will leave an oily patch on the paper within minutes. So, this confirms adulteration in petrol. Now, next we will see the preliminary examination of kerosene. Visually, if we see that if we note down the color of the sample visually, we can see if there is an adulteration. In UV visible spectrophotometry, note down the wavelength from 600 nanometers to 700 nanometers for blue color using visible spectrophotometer. For spectrophotometer and for oil blue dye, the maximum wavelength is 645 nanometers to 655. This is for dialkyl amino anthraquinone dye, which is normally used for coloring PDS kerosene. The third method is TLC and HPTLC for detection of kerosene. The solvent system that we are going to use here is hexane, toluene and acetic acid, again in the same ratio of 50:50:2. The development will be by a spray plate with rhodamine solution, which is again 1% in alcohol, followed by bromination. Then the plates will be observed under UV light at 366 nanometers. The observation will be bluish violet fluorescence for kerosene. If we see this bluish violet fluorescence, that means kerosene is present. The fourth test is thin layer chromatography methods for the detection of oil soluble dyes. The solvent system that we can use here is hexane, toluene and acetic acid in the same ratio of 50:50:2. The developing reagent here is different, which is dilute sulfuric acid. What we observe is blue color spot at 0.4 retention factor. Confirmatory examination for ethanol, methanol, acetone and chloroform. The first confirmation can be done by gas chromatography. It is employed for examination of most of the volatile organic solvents. Many laboratories prefer GCMS as an analytical method for detection. The second method is spectrophotometric analysis. With UV spectrophotometer is used to detect particular solvent in different wavelength range, because each solvent absorbs UV radiation at specific wavelength. The third confirmatory examination for petrol and kerosene is by high performance liquid chromatographic method. We call it HPLC. In HPLC, the stationary phase is solid and the mobile phase is any organic solvent or liquid. This type of chromatography is generally employed for examination of naphthalene, 1-methyl-naphthalene and 2,6-dimethyl-naphthalene that are present in petrol. The second method can be gas chromatography. Gas chromatography is a separation method of choice in which the stationary phase is solid or liquid and the mobile phase is carrier gas like hydrogen, nitrogen, helium, etc., used for separation of analytes from sample. This technique is used to identify petrol, kerosene, petroleum hydrocarbons, solvents, petrol, kerosene admixtures and petroleum solvent admixtures. This method is more specific, sensitive and reliable when coupled with mass spectrophotometer. The gas chromatographic method is used in the identification of common adulterants in petrol such as naphtha, special boiling point solvents and other industrial solvents, which invariably lead to lowering of research octane number, that is RON. The capillary gas chromatographic method of analysis for understanding the chemical composition of the adulterated petrol is explained in detail with equipment configuration and operating procedures. The third instrument which can be used is Fourier transform infrared spectroscopy. We call it mid-FTIR. FTIR is useful technique for the analysis of concentration of oxygenates, aromatics and olefins in petrol and petrol oxygenates blends, and for the prediction of research octane number, the vapor pressure and the distribution properties. It also tells about distillation characteristics of petrol. The first importance is the accidental poisoning is common with organic solvents like chloroform by inhalation while working in laboratories. Second, chloroform is inaberrant poison, so mostly it is used by kidnappers to make the victim unconscious. In this process, chloroform is sprayed directly on the nose or it is used with the help of a cloth. Third, methanol works as a dangerous poison. It may cause blindness when its fume come in direct contact of eyes. In homemade or undistilled alcohol, methanol is present in a small amount, and when person consuming such liquor due to chronic poison, he or she becomes blind. The fourth importance is ethanol causes liver toxicity when it is consumed in large amount daily. Death may occur after months or year due to excessive use. The fifth important use is petroleum and kerosene are generally examined for their quality. Generally, petrol is adulterated with kerosene because PDS kerosene is cheap in comparison to petrol. Kerosene is tested for dyes added in them for identification or its quality. The sixth point is kerosene is used for suicidal purposes. It may be used to pour on clothes one wear and then clothes may be ignited. The majority of cases have been young children who have taken kerosene by mistake for water or any other fluid. Isolated cases of petroleum poisoning have been recorded among persons attempting to suck petrol out of car tanks through a rubber tube and becoming choked by a sudden rush of petrol into the mouth and throat. Seventh point covers homicidal attempts by pouring kerosene on the clothes and igniting them, so that this is not uncommon in our country. Dowry deaths. The next point is petroleum and kerosene is also used in arson cases where traces may be present around the crime scenes. Ninth, volatile substances may be poured into the container for sniffing, or it may be huffed, sprayed on a cloth, held on a mouth, or bagged, sprayed on a plastic bag and then inhaled. Abusers often begin with sniffing, that is lower concentration, and progress subsequently to huffing and bagging. This means higher level of exposure. 10th, as acetone is used in many household work, mainly in nail paint removers, so chronic poisoning may occur if to woman when she is continuously using it. And in this lecture series, you all have been learnt about the organic solvents, their properties, classification, usefulness and where they can be used. Now, you all are aware about metabolism of some common organic solvents, when it entered into the body, examination technique used for detecting them and their forensic importance. With all this information here, we come to the end of today's lecture. Do keep in mind what we discussed today. It is time for you all to do some self study. This is Dr. Abhilasha Durgvanshi signing off. If you want to learn more and enhance your knowledge, you may log on to our website for MCQs, quizzes, LORs at www.cec.nic.in. Till then, goodbye.